The advanced sound ranging program, ASP, utilizes the science explained in the video to locate the indirect fire from enemy guns, mortars and rockets. If you think back to the video you have just seen, it shows that sound is a mechanical disturbance of particles that travels through a medium. For ASP, this mechanical disturbance is the enemy gun, mortar or rocket launcher firing from their positions on the ground. If you can imagine standing by the side of a swimming pool, you pick up a stone and throw it into the pool. As the stone enters the water, it creates concentric waves that continue to move along the water. The stone hitting the water represents the weapon firing, the source of the sound, and the waves represent the sound traveling through the medium. The ASP system has microphones that are placed on the ground. We refer to them as sensor posts. These sensor posts listen for the enemy forces firing and can tell us the source of that sound, which is the location of the enemy firing position. So, how is the ASP system able to do this? Imagine that the sensor posts, the microphones on the ground, are your ears. If I were to ask a group of you to make a big circle around me and close your eyes, and when you hear me sound a bell, point in the direction of that sound with your eyes still closed, you will all point in my direction. If once more I were to ask you to close your eyes, and again, when you hear the bell, point in its direction, but this time I will have moved from the center of the circle to a different location, you will all still point in the direction of the bell, but some of you will have turned to face it. That is basically how ASP works. The bell is the enemy forces firing rockets, mortars or guns. You are the sensor posts, microphones on the ground. The microphones work in a similar way, by pointing in the direction of the sound of the weapon firing. We try to place the microphones on the ground, pointing in the direction of where we think the enemy might be firing from. When the sensor post microphones detect a possible sound of an enemy weapon firing, each one of them will draw a line in that direction. Where the lines all intersect, in other words meet, that is where the sound is coming from. The more microphones that pick up the sound, the more accurate we can be at detecting the exact position of the enemy.